Dear students, now let us solve 16th question of exercise 2.5 from triangles lesson. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. Now draw an equilateral triangle. Triangle in which all sides are equal is called equilateral triangle. Now ABC is a equilateral triangle. Take its side length equal to A. Now what we have to prove? To prove 3 times, that is 3 into square of one side. Here all sides are equal, so length of the side is A, so 3A square. To prove 3 into A square is equal to 4 times, means 4 into square of one of its altitudes. Now draw altitude of an equilateral triangle. Draw altitude from A on BC. Now AD is an altitude from A on BC. Now we have to prove 3A square is equal to 4 AD square. You know that altitude of an equilateral triangle bisects the base. Here AD is the altitude drawn on BC, so it bisects BC. AD bisects BC, means BD is equal to DC. Length of BC is equal to A, so BD is equal to half of A and DC is equal to half of A. BD is equal to DC is equal to half of A. Now we have to prove 3A square is equal to 4AD square. We want AD square to prove, so we have to apply Pythagoras theorem to triangle ADB, which is right angled at D. Angle D is 90 degree, so AB square is equal to AD square plus BD square. In right angled triangle ADB, AB square is equal to AD square plus BD square. Now AB is equal to A, so A square is equal to AD square plus DB is equal to half of A, so half A whole square. Now A square is equal to AD square plus half A whole square is equal to A square by 4. Now A square minus A square by 4 is equal to AD square. That is 4A square minus A square by 4 is equal to AD square. 4A square minus A square is 3A square by 4 is equal to AD square. That implies 3A square is equal to 4 AD square. Hence proved. We proved 3A square is equal to 4 AD square.